Introduction to exponents. We often come across very large numbers. For example, the distance between the Sun and the Earth is approximately 150,000,150 million kilometers. Denoting 150 million kilometers in figures is a tedious job. Every time one needs to write 9 digits. We can express this in another way. As 15 is followed by 7 zeros, the number can be expressed as 15 times 10 to the power 7 kilometers. Now, the second number is 10 multiplied by itself 7 times. We also call it the 7th power of 10. We are interested in the term 10 to the power 7, as that leads us to the concept of exponents. 10 to the power 7 denotes that 10 is multiplied by itself 7 times. Here the number 10 is called the base, and the number 7 is called the exponent. An exponent simply tells us how many times 7 here, the base 10 here, is multiplied by itself. When we deal with numbers, we may prefer to deal with thousands, or millions, or billions instead of exponents. For example, the approximate world population is 7,000,000,000,000, which is written as 7 billion. This is 7 followed by 9 zeros. But when variables are involved, we need exponents, because it is easier to write or say x to the power of 6 than x times x times x times x times x times x. Exponents are effective in expressing extremely small numbers too. For example, the radius of an atom is approximately 0,000,000,000,000,001 meters. If we write this extremely small number in the form of a fraction, it can be written as 1 over 10 to the power 10 meters. Note that the exponent of 10 appears in the denominator. This can be denoted with a negative exponent. A negative exponent simply tells us how many times you have to divide 1 by the base. Here, 1 is divided by the base 9 times. In summary, an exponent tells us how many times the base is multiplied to 1.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.